Imagine standing at the edge of the Grand Canyon on a warm afternoon, staring down into the vast, carved wilderness of layered stone. The Colorado River glints faintly at the bottom, a thin ribbon of water that took millions of years to sculpt the landscape. But now imagine something impossible. Instead of a river, the entire canyon is filled, brim to brim, with water. An inland sea stretching for hundreds of kilometers, shimmering under the sun. What would that even look like? And what would it do to the world around it? The moment water begins to pour into the canyon, the process is more dramatic than anyone expects. The Grand Canyon is not a smooth bowl, it's a labyrinth of cliffs, narrow passageways, massive drop-offs, and steep ravines. As water rushes in, it funnels violently through the tightest sections, creating temporary waterfalls hundreds of meters tall. The walls amplify the echoes into a roaring thunder that shakes loose rocks from ledges that haven't moved in centuries. Dust clouds rise and swirl as the canyon slowly drowns. Within days, the lower levels fill completely. The deep carved channels disappear beneath rising water, leaving only the widest basins visible. As the reservoir continues to grow, it swallows entire hiking trails, campsites, and lookout points. Even some of the famous rock formations, towering stone pillars like Vishnu Temple and Zoroaster Temple, begin to transform into lonely islands jutting out of the surface. The higher formations become small archipelagos, while others vanish completely beneath the growing lake. The canyon's geology, normally seen in colorful exposed layers, becomes hidden underwater for the first time in millions of years. After weeks, the process stabilizes. The Grand Canyon, one of Earth's largest natural scars, has become one of its largest artificial lakes. Locals call it the Grand Sea, and from space it looks like a sapphire tear along the desert's surface. Its changing depth creates new currents and temperature gradients. The lower waters remain cold and dark, untouched by sunlight, while the surface warms under the Arizona heat. Small artificial beaches appear along the canyon's upper rims, and new coastal towns spring up where tourists once stood to take photos. But the new body of water alters the region in deeper, unintended ways. The dry desert climate surrounding the canyon begins to shift almost immediately. The vast surface of the lake evaporates under the sun, injecting enormous amounts of moisture into the air. Within a year, rainfall patterns across Arizona and Nevada change dramatically. Storms form more frequently, drifting across the plateau and releasing precipitation on land that has been dry for thousands of years. Plants take advantage of the new ecosystem. Grasses and shrubs spread outward from the lake's edges, followed by birds, insects, and eventually larger animals seeking the new water source. The temperature of the region cools slightly, moderated by the new lake acting as a massive heat sink. The once scorching summers become a bit more forgiving, and winter nights become warmer. Weather stations record a clear shift in humidity levels. What was once an arid desert begins to resemble a semi-arid savanna, a slow but persistent transformation driven by evaporation and rainfall. Yet the environmental consequences extend even farther. Because the new lake is enormous and deep, it influences wind patterns on a continental scale. Moisture from the Grand Sea sometimes drifts into neighboring states, creating unexpected storms in New Mexico and Utah. Dust storms, once common, become less frequent as the soil binds with increased rainfall. The region's air quality improves. Even migratory birds alter their ancient routes to include the new oasis in the desert. Human behavior shifts just as dramatically. The new coastline becomes a hub for sailing, fishing, and tourism. Artificial harbors allow boats to explore the flooded canyon, navigating through former cliffs now hidden beneath the surface. Divers discover submerged trails and rock formations, transformed into eerie underwater landscapes. Researchers study the strange new currents created by the canyon's unique shape. Engineers attempt to harness the lake for hydroelectric power, though the sheer depth makes it difficult. Fishermen introduce species of fish to populate the waters, but biologists worry about unintended ecological consequences. Still, not everything goes smoothly. The immense pressure of billions of tons of water pushes outward on canyon walls, causing landslides in unexpected places. Entire cliff sections collapse into the lake with thunderous crashes, sending waves across the water's surface. Scientists monitor the canyon constantly, worried about long-term structural changes. Some fear that if enough pressure builds in the wrong place, parts of the canyon might rupture, sending water spilling violently across the desert floor. And there is the question of the Colorado River itself. With the canyon full, the river no longer carves its path naturally. It backs up, forming new tributaries and altering river flow throughout the southwest. Reservoirs like Lake Mead and Lake Powell become unstable as the hydrology of the entire region shifts. Water rights, already a contentious issue in the American West, become even more complicated as states negotiate over the new water distribution. Yet despite all the upheaval, the Grand Sea becomes part of life. Children grow up knowing it only as a lake, not a canyon. Maps redraw themselves. New species adapt to the environment. And while geologists mourn the loss of one of Earth's greatest natural archives, a record of millions of years of history, they also recognize that the planet is always changing. The Grand Canyon once formed from running water, and now, in a strange twist of fate, it has returned to water again. And for someone standing on its edge, watching the sunlight shimmer across a vast blue surface where a desert chasm once lay, it might feel like witnessing a piece of Earth's history rewrite itself in real time.